Okay, let us discuss problem number 2.54. This is again an easy problem. This is 1 mole of ideal gas. So number of mole is 1 and it's 1 mole. And the gas is ideal in nature. So 1 mole of ideal gas with heat capacity at constant pressure Cp is given. Goes through a process, and the equation of process is given. Goes through this process, T is equals to T naught plus alpha V. So goes through this process, T is equals to T naught plus alpha V, where T naught and alpha are constant. So T naught and alpha are constant. Now the question says, first part, find heat capacity of gas as a function of volume. So we have to find heat capacity as a function of volume. Now how will you proceed this one? So we have already derived that a heat capacity is given by dq by dt for 1 mole of gas. So let us divide by n. And dq is nothing but du plus dw divided by n into dt. Now everybody knows this du is ncv dt and dw is p dv divided by n dt. So we will have next line, so n dt goes out, so cv plus p dv divided by n into dt. And Cp is given, and everybody knows for ideal gas Cp minus Cv is equals to R. That is Cp minus Cv is equals to R. So Cv is Cp minus R. So I can write here Cv is Cp minus R because Cp is given. And then I have to eliminate P dV divided by n dt. So you have to eliminate this term and you have to write as a function of volume. So let us say you do something, you eliminate P dV and dt. So you eliminate this P dV and n dt as a function of volume. You have to write the final answer. Let us say initial volume is V1 and final volume is V2, that is given to you. So you have to write final answer in terms of volume. Okay, let us see. I have PV is equals to nRT and T is given by T naught plus alpha V. So I can write PV is equals to T is given by nR T naught plus alpha V. Are you getting? Now I need to eliminate dt. So how can we proceed? Let us think. Okay, so what we can do is we have equation for temperature, that is T is T naught plus alpha V. If we differentiate this equation, I need dV by dt. So let us differentiate this equation. So dt is equals to alpha times dV. Are you getting? So alpha times dV. So from this equation we will have dV by dt. This is equals to 1 by alpha. And pressure I can get from this equation. So pressure is nR T naught plus alpha V divided by V. So this is the pressure. Now you have to plug all these two things in this equation. So C will be Cp minus R plus P dV. So P is this, and R T naught plus alpha V divided by V into dV by dt. dV by dt is 1 by alpha. I have to also multiply by n. So this n goes out. So what we will have, Cp minus R and RT naught by alpha V plus RT naught by alpha V. This is alpha into V plus alpha V goes out, so we will have simply R. So this R goes, so we will have Cp plus RT naught divided by alpha V. Are you getting? So this is the value of heat capacity. Only thing is, in this kind of question in which you have to find heat capacity, you have to eliminate this dV, dt, all these terms. So dV, dt, and for that what you can do is, you can try equation of process, you can differentiate equation of process, you can differentiate ideal gas equation, and you can just put the equation of process in ideal gas equation, and then you also differentiate. So after differentiating and doing some mathematics, you will get the desired result. Now B part of the question says, find out the work performed, work or heat. Let me see. So the amount of heat transferred to the gas if the volume increases from V1 to V2. So you have to find, if the volume changes from V1 to V2, what is the heat transferred? So amount of heat transfer, we have to find it out. Amount of heat transferred. So now how we will find amount of heat transfer? So this is simple. You see, our temperature is given by T naught plus alpha V, and now I know capacity, heat capacity C. C for this is Cp plus RT naught by alpha V. This we have derived in the first part, and now I can use this. C is defined as dq by dt and dt. Are you getting? So what we'll have from here, I can write dq is equals to nc dt. You getting? Now dt is nothing but, so if you see this equation, dt is nothing but alpha dv. So I can put this one here. So dq is equals to nc dt is nothing but alpha dv. Are you getting or not? Question also says, if you see the first part, this is done for 1 mole of gas, so n is equals to 1. So 1 into C into alpha dV. Now if I plug the value of C, C is nothing but Cp plus RT naught by alpha V. So Cp plus RT naught by alpha V. So this is C into alpha, and dV is nothing but alpha dt. So alpha dV is nothing but T by, so let me write here so that you can understand. T is equals to T naught plus alpha V. If I differentiate, we will have dt is equals to alpha times dV. So what we will have, dV is equals to dt by alpha. I need only dV. I have already converted into, so dt I have already given. dt is equals to alpha dV. I want answer in terms of dV. So let us say this is dV. Are you getting? So what is the heat required? So dq is equals to Cp plus Cp dV plus RT naught alpha by alpha V dV. So this becomes, I think all of you have copied this one. So dq is equals to Cp dV plus alpha goes out. So we will have RT naught dV by V. Now I can integrate this equation to find out the total heat. Volume goes from V1 to V2. Here also V1 to V2. So this is the heat transfer to the system. Q is equals to Cp V2 minus V1 plus R T naught ln V2 by V1. Are you getting? So this is the heat transferred to the system. So you check your answer. This is a pretty easy problem you have in this case. N is given in the question, number of mole is 1. So you can put N is equals to 1. If you have copied this one, then I can go for the next problem. These are easy problem basically. You will do this kind of 1-2 more problems so that you can feel handy in differentiating the equation, in differentiating the PV is equals to nRT, in differentiating the combined equation in which you put the given equation in PV is equals to nRT and you differentiate. So these are the things you have to know. Let's go to the next problem.